In this video, we'll discuss about the preparation of colloids. How do we prepare colloids? The preparation of colloids. So let me take the first method, preparation. That is what? By using some chemical methods. First type is what? Chemical methods. By using some chemical reactions, we are producing the colloids. Next, what are they? What are the chemical methods we are having? Method we are having double decomposition method. We have what? This double decomposition method, we take what? Isn't it? AB plus CD. In double decomposition method, we'll convert into AD and CB. That means this D will displace here and this B will displace here. Then in this way. Now let me take one example here, arsenic oxide reacting with hydrogen sulfide to give arsenic sulfide. This is the colloid we are going to get in this. This is the colloid we are going to get in this solution. Called what? Double decomposition reaction later. What happened here? The sulfur and oxygen displaced like this. So arsenic oxide, when react with hydrogen sulfide, give arsenic sulfide is what? Double decomposition method for the preparation of colloids. This is called what? Colloid solved for us here. Next, second method, if we take oxidation method. Now, what is this oxidation? Let me see. Loss of electron generally called oxidation. Let me see this one, sulfur dioxide reacting with hydrogen sulfide, oxidation reaction took place to give sulfur sol. This is oxidation reaction here. See here, the sulfur oxidation state is -2. Here it is 0. So loss of electron oxidation reaction. So this is an oxidation reaction for getting what? Sulfur sol action, right? Your oxidation state is what? -2 converting into 0, loss of electron. So we got sulfur sol. This is a chemical method for the example called oxidation reaction here. Next, reduction reaction. What is reduction reaction? Addition of electron. Take this one example for reduction. I have taken RM chloride on reacting with formaldehyde with water. This RM chloride is converting into RM sol here. Now, if you observe what happened, this RM is having +3 oxidation state, and this is 0 oxidation state. So, conversion of +3 into 0 is called what? Reduction reaction. And this will undergo oxidation. This will undergo oxidation reaction. Which one? Formaldehyde, right? So, +3 converting into your 0 is called gaining of electron reduction. So, RM chloride converting into RM sol, colloid solution by the reduction. We will take what? Hydrolysis method. What is hydrolysis? So generally what happens, addition of water, it's called hydrolysis reaction. Now if you take FeCl3 on reacting with water undergoing hydrolysis reaction to give what? Iron hydroxide sol. This iron hydroxide sol can be called as what? Isn't it? Colloidal sol. By what? Hydrolysis here. So ferric chloride converting into ferric hydroxide in hydrolysis process. We can take an example for what? Sol of ferric hydroxide can be obtained by definitely what happened? Sulfur sol can be obtained by definitely what happened? Reduction method, isn't it? Sulfur sol can -2, no, sorry, oxidation because H2S converting into what? Yes, sulfur. -2 is converting into 0 is called oxidation process. Next, preparation of colloid. Second type, if you observe, Bredig's method. Bredig's arc method, let me take it. Now, what is Bredig's arc method if you observe here? This process involves dispersion as well as condensation. What is this dispersion? Let me take it. A dispersion is a system in which particles are dispersed in continuous phase of different composition or state. Let me take this example. Condensation, already you know this one, gas converting into liquid. Actually. That is different. Already you know this one. Condensation means what? Gas converting into liquid is called condensation. You take the dispersion, how it takes place here. Water vapor condensed into the liquid. It's a condensation process here. Colloid salts, metals like gold, I am taking it. Gold, isn't it? Silver, isn't it? We are taking these examples, and the platinum also we can take. So these things can be taken in this example. We can take silver, gold, and platinum. We can take it. Now let me take here what method, how it is dispersion and condensation. I have taken something dispersion medium. It is dispersion medium. I have taken something water here. Dispersion medium. This is ice bath. For condensation, for cooling condensation, we have taken ice bath. Then these are the electrodes of metal. Whatever the metals you are taking, you can take arum or you can take silver. Anode and the cathode I have taken like this. Okay. Now, in this method, electric arc is struck between the electrodes of the metal immersed in the dispersion medium. So, when these two touch with each other, okay. So, actually, you have when the electricity is applied to this one, you are applying some battery over here. So, something what when electricity is applied, what happen here? Now, these two are meeting with each other. When they meet with each other, when they contact with each other, what happen? A spark is generating. This spark is generating. Now, this spark melting this whatever the electrodes here. This part melting the electrodes here. So because of what happened, due to intense heat liberated because of what this flame leads to what actually vaporization of this metal, and that will condense to form into particle size. So they are getting vaporized, you see, both anode and cathode, they are getting vaporization taking. Because of heat, what happened? Metals are getting vaporized. And these vapors again coming back into what here? Liquid state. In which size? Colloidal size. Okay, these vapors are converting into liquid state in condensation process and converting into colloidal size. Therefore, you are going to get, isn't it, a solution. It's called gold sodium. But take gold as electrode, we get a gold sodium. Right? So this is called Bredig's arc method. So what is the phenomena is taking place? One is what? Dispersion, other is called condensation. Both are taking place. What type of metals we can take? Silver, arum, and gold can be taken for this type of. Next, we take peptization method. The third method will take what? Peptization method. What is peptization? Let me see. It may be defined as the process of converting precipitation into what? Colloidal sodium. Okay, the suspension we are converting into colloidal sodium. By shaking with a dispersion medium, a suitable dispersion medium in the presence of small amount of electrolyte. So converting a precipitation into what? Colloid. How? By shaking this precipitation in a dispersion medium, adding an electrolyte this one. Adding an electrolyte. What is electrolyte? In the last class I told you that. So the electrolyte used for this process, whatever the electrolyte you are using, no, that is called what here? Peptizing agent. The agent which brings the peptization is called what? Peptizing agent. So conversion of precipitation into colloid is called what? Peptization with addition of a suitable dispersion medium and the electrolyte. This method is applied generally to convert freshly prepared precipitation. When you are in the reaction mixture, if you get freshly precipitation, that freshly prepared precipitation will convert into what? Colloidal solution by adding some electrolytes. It's a very, very important definition, peptization. Conversion of precipitation into colloid with action of what? Electrolyte. We'll take one example for this one. So here, this is the precipitation we are getting. This is the precipitation you got. This is the precipitations. Okay, precipitation is nothing but what? Some of the mass accumulated at the bottom of the soil, whatever the dispersion medium. Now I added something electric. This is a suitable dispersion medium. Better. This is the dispersion medium. We have dissolved this everything precipitation. Take anything water. Added some electrolyte. You added some electrolyte, something NaCl like that. You added some electrolyte like this. You added something electrolyte here. Now, when you add electrolyte, what happens during the peptization? When you are adding the electrolyte, the precipitate absorbs one of the ions of the electrolyte. Now, whatever the ion, isn't it? Whatever the ion, this is absorbed by whom actually? These precipitate molecules. This causes the development of what? Positive or negative charge on the precipitation. So on the precipitation, you may get what? Positive charge or something negative charge. It ultimately breaks up the smaller particles of the size of the colloid. Now, because of this, isn't it? The positive negative charge which are present on the precipitation will what actually breaks this precipitate molecules into smaller size like this, into colloidal size like this. They can be broken into up to what? Colloidal size here. And see this one. This is the electrolyte, isn't it? This because of the charge of the electrolyte, the size of these precipitate molecules are now converting into colloidal size. Now we got the colloidal solution. Now this process is called precipitation, peptization. Of the electrical disintegration or Bredig's arc method involves dispersion and condensation methods. Both will be involved here. The process of converting a precipitate into colloidal solution is called what? Definitely, it is a peptization. About the preparation methods of what? Colloidal solution.